good afternoon and welcome to this post-lunch session. So already you got a lot of inputs on microgrid, electric vehicles, and a lot of mathematical equations, right? And like that. So I try to make this lecture in a very simple way so that you can understand. So I came to know that people are from various, you can say very diversified background. So students are also there. So right from students to the practicing engineers and your faculty members. So you people are doing a lot of work in this field. So just after this lecture, we will be having a panel discussion also. That is also based on this topic. So this is very important topic, you can say, microgrid and load frequency control. So as of you know, how much installed capacity we are having right now? Can anybody give any figure in India? How much installed capacity is there? Yes, sir. Yes. So that is huge. That's why I have asked this question. So we have just crossed 500 gigawatt of installed capacity. So that is a very huge capacity. So the responsibility of the, you can say, power sector and power system operators is becoming very huge and large. So I will just try to sum up because the time is very less, 30 minutes. So I have to sum up. So I will go through. So please be here with me. So I will. So this is just a background. So just in the few initial slides, we will see where our power sector is. Okay, where do we stand in terms of installed capacity, right? Then we'll come to this distributed generation EV. A lot of lectures already have been conducted on these topics, right? Then we'll see this load frequency control, right? This is a very important topic in this present era where we are talking about even DC microgrid also. Okay, so AC microgrid and DC microgrid, they can help you at the distribution level. So a lot of things are there. Then we'll see why this frequency control is very important, because you know this frequency gives you the overall means this is the indication of the overall functioning of the power sector. Okay, so if your system is working at its nominal frequency, it means things are under control. So it means power controllers, or you can say control engineers, they have their eye only on that clock, how much your frequency is there. So if you do not attend the power sector, right, that may result even in blackouts and grid failure also. So in 2012, July 30th and 31st, we have seen two blackouts, okay, in the consecutive days. So that is the thing. So that's why this topic is very important. So recently we have got one book also, that is Load Frequency Control of Microgrid. So that is recently published by Taylor and Francis. So 4 people were there. So our Director General Pippal was also there, and Professor K.P.S. I think you might be going through his books in first year, second year, and electrical machines also. So it means people are started addressing on these issues. That's why these books are coming up. So just going through. So this is just a quick, because you should know what is the power sector. So generation, transmission, and distribution. I will go through very quickly. So you all are aware that generation is up to the 30 kV. Okay, worldwide. If you say so, it means up to 30 kV we are generating, and in India, our transmission is as high as 1200 kV ultra high voltage AC. Then again we are coming to our distribution side. Okay, then we are utilizing 415 volt 3 phase and 230 220 volt single phase. So you can understand it is right from generation, then you are doing transmission, distribution, like that. So this is the overall functioning of the power. And so Anuj is here, so from Grid India. I think so far this was the highest 250 gigawatt of peak load. So why I have taken this slide? This slide is very important. Okay, इस slide के पीछे ही हम लोग चल रहे हैं. Okay, so we are now see 250 gigawatt we have got, and we are talking about 500, more than 500 gigawatt of installed capacity. Okay, so why we are celebrating at 250? So just BTEC के बच्चे बताएं. 500 gigawatt installed and your peak is 250. Okay. So इसमें क्या? What is great in this? Any guess? So this is the thing basically. Okay. Water installed capacity means you're not having that capacity at a time. Okay. It means that capacity is not being served continuously, right? So you can start right from thermal power plants. Thermal power plant, their plant load factors are around 60-70%. Okay. Even solar also, whatever you are seeing, megawatt, kilowatt. So that is kilowatt peak. Megawatt peak, okay, not exact. Okay, the peak means what is that solar panel will give you some output in the ideal conditions, like that. It means laboratory tested data is there, right? So that's why you can understand. So 250 gigawatt was the huge, and how we were able to meet that demand, 250 gigawatt, due to the interconnectivity of the several regions. So right now we are having national grid. Okay, so one nation, one grid, and one frequency. So due to this formation of the national grid, so all the regional grids are connected. So you are enjoying that flexibility. It means you can transmit the power from the area of surplus to the area of deficit. So that's why it means you are able to meet this demand. So this is very important. 250. This is the recent data I have taken right from Grid India itself. So this is the 11th November data. So here you will find. This is very important, okay. Shortage or surplus. Okay, here you will see zero, right? So recently our Honorable Minister of Power said during the NHPC program, earlier we were having sufficient power, okay. But now we are having surplus power. So this is announced officially. We are having the surplus power. So it means what the grid management becomes a very huge task. So just have a quick look at this data. So here you will see that renewable penetration. If you exclude that large hydro, the renewable itself is around 197 gigawatt. Renewable, okay. And then thermal 246, and then 50 gigawatt around hydro. And nuclear constant आप इसमें कोई ज़्यादा addition आपके नहीं हो रहा है. Okay, like that. So what is happening? It means now renewable is having a major portion. So that's why we are talking about inertia also. Okay, it means how to manage the grid. So that is the challenge. So we'll talk about that also. So this is the further data, right? This also you can go through the slide. This energy resource map is very popular whenever we talk about this. So why this national grid was important, and you can understand here each and every region. So the entire India, okay, it means power system in the India has been divided in 5 regions, okay. So eastern, western, northern, southern, and northeastern. So 5 regions are there from the administrative point of view. So we are having 5 regional grids also, and 5 regional load dispatch centers also, and also we are having 1 national load dispatch center, like that. So each and every area is having its own characteristic. You can say your J&K part and northeastern region, they are very rich in hydro. Okay. Then you can say your central India is very rich in thermal, and then other states are, it is not all the states, but few states are very rich in solar and wind also. Although wind and solar is distributed. Okay. So it means what? We have to manage, not only physically. So if you look at the previous slides, what was the challenge? It means we have to connect all the regional grids, right? So that we can make optimal utilization of all the resources. So it means generating stations are having their own areas, like thermal power plants. They are very site specific. Okay, where to install the thermal power plants? Wherever you have the nearby coal mines, because transportation part is the major issue for the your fuel, coal, right? Hydro is also site specific, specifically large hydro power plants. Okay, of course you are having distributed generation for small hydro plants or small hydro projects. So they are up to 25 megawatt, like that. So it means what? If you have one national grid, all the regions are connected, so you can make optimal utilization of the resources. So in the similar line, government of India, okay, also they are now Grid India, okay. So they had to interconnect all the regional grids. So they have started right from 1991. So 1991 they have connected this east and northeast, okay. Then 2003, they have connected east, northeast. So that was known as central grid. Okay. Then August 2006, they have synchronized this central grid. Okay, with northern grid. So that was known as new grid. काफी समय तक इसको new grid बोला गया. Then in the last 2013, they have synchronized this southern grid also. So in that way, they have formed the national grid. Why this is important? You can correlate all your discussions with this concept. Okay, you talk about microgrid, AC grid, DC grid, but if your grid is not single and robust, okay, this is of no use. If you are having generation, because we talk about resource adequacy also. So suppose you are having a generating plant, but no transmission network is there, right? So there is no use of generation, right? So it means you have to plan each and everything: generation, transmission, and distribution. Okay, am I audible? Last, so generation, transmission, and distribution. So that's why this slide is very important. And now, why distributed generation and microgrid is important? Because energy security is very important part for any nation. And for fossil fuel and non-fossil fuel, we are having two categories. So in the fossil fuel, it means you have limited stocks or poles, and then certain environmental issues are also associated. Okay, so it means what? We have to look at other alternative sources, and alternative sources are renewable, because we are very rich in wind and solar. If you look at the potential, wind potential and solar potential in India, so approximately, if I am correct, it is 750 gigawatt around for solar itself. Okay, and 700 to 750 gigawatt for wind. So you can understand, it means 1500 gigawatt you can harness through solar and wind if you plan it properly. So that much of huge capacity we are having. So why distributed generation and microgrid? These both things are very correlated. Microgrid आपको क्या होता है? What is the microgrid? It means at a small level, whatever protection you are having, okay, that is known as microgrid, right? So suppose you have some plant of 10 kilowatt, 50 kilowatt, okay, or you can say more than this, right? So it means you are having the microgrid. And what is the advantage of having the microgrid? You generate locally and then supply locally, right? That is the advantage. Of course, you can operate these microgrids in both way. It means it may be either grid connected, or you can run in islanded mode or in standalone mode also, right? So that is the advantage of microgrid. So both beauties are there. So it is up to you how to decide. So many microgrids are there. In morning itself, we have seen in the lecture also at IIT Patna, they have installed their microgrid also. IIT Kanpur is also doing some villages there. Okay, I am forgetting their name. So that is the pilot project. So they are working on that, and they commissioned that successfully also. अभी ग्रिड से यूटिलिटी से कनेक्ट किया कि they were under the process with KSU. So Kanpur, like that. So this distributed generation, you can say, and microgrid is very important. So we'll see. So it is very difficult how to define a microgrid. Okay, in the literature, you will see some people say the plants around 40-50 megawatt, up to 40-50 megawatt, you can put under this category distributed generation. Okay, IEEE says 1 to 2 megawatt, very small level up to, okay, we can put like that. So it's all right. So that capacity doesn't mean, but what is important, it means protection at a smaller level. Okay, so it may be at the grid connected or in the standalone mode. That is very important. So, okay, it's all right. Already you have got many definitions of microgrid. So modes of operation, that is very important, right? Like in the morning, sir was telling that that state utility is not paying them. Okay, they have connected their solar like that. So there also, I think, you know, there are two concepts: net metering concept and gross metering concept. Okay, for solar power generation. So it depends upon the state. Okay, what are their regulations and in what way they are promoting their distributed generation. So that depends. So in the modes of operation of microgrid, it may be this we have taken from our book only. इसमें जो भी आपका discussion है. So here it means we are having this circuit breaker. Okay, this is a point of common coupling, and this is your utility grid, you can say, right? So if it is disconnected, means islanded mode, right? And if you connect, it means it is utility fed. So two modes are there. Here you will see distributed generation (DG), energy storage system, and load. Basically, whenever we talk about the microgrid, suppose you are having solar system, right? So right now we are having around 127 gigawatt of installed capacity. Okay, that is coming from solar itself. But what happens when sun sets? That 127 goes off, and mostly we are having the power plants without storage. Mostly, okay, very few are having some storage. That is also very less. But now government of India made it very mandatory. So now solar power plants are at whichever plant is coming up. Okay, so they made it mandatory. I think around 10% capacity should come from energy storage, right? Also, some draft regulations are there for discounts. Also, they are also mandated to put some battery storage. Okay, unless and until you make it very compulsory or mandatory, then only you can promote. For renewable also, if you see the history of the renewable energy, government of India made it mandatory. Certain percentage you should mix. Suppose NTPC is there, so certain portion should come from renewable also. In that way, they got. So that's why we are having it now our fossil fuel and non-fossil fuel. So non-fossil fuel capacity has crossed the fossil fuel. Okay, it means now it is more than 50%. And what is the target? We have to add 500 gigawatt of capacity from non-fossil fuel, and that is by 2030. And by 2070, we have to make net zero carbon emission. Okay, like that. So these all are our ambitious targets. So these are giving some challenges also. इस पे आप लोगों ने ऑलरेडी काफी डिस्कशन किया है, तो मैं इसको ज्यादा नहीं करूंगा, टाइम बहुत लेस है आपका, राइट? ये सब यू ऑल आर अवेयर ऑफ द नेक्स्ट. सी this is the IFCPAR definition. Okay, where can you put your DG sources, right? So up to 1 or 2 megawatt. Next. So we are coming to this. It means how we are implementing the things. Research is at one end, but implementation is very important. How to implement, right? So various models are coming up, right? You can say the first is V1G. आप सबको पता होगा V1G. What happens in the V1G mode? Only charging. Okay, whatever electric vehicles you are having, you are going at the charging station, you are charging and running like that. Nothing else, right? But in this V2G mode, vehicle to grid, you have bidirectional flow, right? So it means what? Your electric vehicle can participate in grid management also. ठीक है? अब इसको हम लोग बात करेंगे पैनल डिस्कशन में. So this is very important. हमने in my research was also in my book. Okay, you can go through that book. That is well compiled book. So that is having the concept of microgrid, then what is the load frequency control, and then what are the state of art optimization techniques. Okay, all your whatever. I think we have explored most of the recent optimization techniques, right? So various chapters are there. So you can go through that. So this V2G is very important. How electric vehicles can participate? Suppose you take example of the JSS. Okay, so how many cars would be there from morning to evening? Many. Okay, like many big universities, hospitals. So you will find that many parking lots are there. Even in colonies, okay, some common parking areas are there. So you can make use of these electric vehicles as energy storage. What would be the advantage of energy storage? आपको अलग से कोई extra cost नहीं लगानी है ना. Otherwise, if you are having the battery energy storage, electric vehicle is also having battery. Okay, but battery energy storage means separately you are having some batteries for this storage purpose. So it means you have to purchase the batteries and you have to work on them, right? But we are promoting battery energy storage also. Government of India has planned. It means they are targeting around 50 gigawatt of storage, battery energy storage by 2030. You can say in the coming years they are planning in a massive way. रिसेंटली आपने सेकी का देखा होगा, एक प्रोजेक्ट है 1 गीगावाट आवर, 1 GWH कैपेसिटी का वो लोग अपना प्लांट ला रहे हैं बैटरी स्टोरेज पे. ओके, सो इन दैट वे वी आर डूइंग इट. So then these are other concepts, vehicle to customer, and then you can say hybrid mode also, right? It is vehicle to building also. You can charge like that. But how can you make utilization of electric vehicles, right? It means how electric vehicles can help in the grid management. What happens? You know, suppose there is some demand and you require the balance, immediate balancing is required. So you know, battery storage is the best option in terms of response. Okay, not in all terms. Okay, otherwise your pumped hydro is you can say most feasible option, right? So battery, they take very less time. Okay, battery can you can say influx the power flow immediately. You can see immediately, right? So now thing is that you have to design a model for this all electric vehicles, because your vehicles are there, right? You have to connect all the batteries. Then you have to design some algorithm also. Okay. Then how many batteries you will put in the charging mode? Okay. And then how many batteries you will put in the discharging mode? Okay. Not like that all the 1,000 batteries are participating in this grid management. So you will check their SOC, state of charge also. Right. So in our research, mostly it means we have taken the charging. It should not be below 80 or 85% discharging also. Okay. So 80, 85, and then up to 95 like that. Okay. Not 100%. Okay. Keeping in view the battery life also. So in that way. So why not below 80 or 85%? Because when that car owner is coming, okay, so he should not get discharged battery. Okay, there is no use. Okay, if you are returning to your home in night and you have contributed a lot in the grid management and your battery is fully discharged. Okay, so it doesn't make any sense. Have you got the point? So that is the challenge for this electric vehicle. It means your controller should be very smarter and robust. That work we have done in that book and in many research work also, and we have explored most of the you can say combinations, whatever feasible combinations are there. We have taken battery energy storage also, fuel cell also, solar, wind, like that. Okay, so now see why this automatic generation or load frequency control is important or required. So first of all, whenever we talk about automatic generation control or load frequency control, okay, so mostly for primary and secondary control. So this deals with the small perturbations in the power system. Okay, so mostly in the literature also you'll find that they consider up to 1% variations. Mostly they test their controllers for step response. Okay, then we are also having some hybrid responses. Okay, ramping and then step up, and then even for sinusoidal kind of variations also. We are also giving some random variations to the system controller, right? So AGC means suppose your frequency is 50 Hz. So nominal frequency is at 50 Hz. So what is the meaning? It means total power generation. You have seen that balance equation in your power system. I think during your study in 7th semester or 8th semester. Okay. So one power balance equation is there. So total power generated should be equal to the total load demand plus associated system losses. So that balancing should be there. Okay. So that is the important thing, right? Grid India is taking care of this balance equation only. Okay. So this equation looks very simple. Total generation should be equal to total load and associated system losses. But the management is very complex. Okay, because in the generation you are having a variety of sources. So similarly here also you are having variety of sources. Thermal is having its own peculiar characteristic, right? Very slow response as compared to other sources, right? As compared to hydro and battery energy storage. So thermal is there, hydro is there, then solar, wind. Okay, then we are also talking about biomass. So this overall management becomes a very huge and complex task, right? So that is the thing which is being looked after by Grid India, basically. So this is the balancing. I'll just try to make it very simple. So see, it means if load is more, right? Load is more, it means what? This will come down, right? And generation is less. Got the point? So it means frequency will dip, right? And when load is less and generation is more, so your frequency will increase. So you have to do that balancing for the grid management. As per IEGC 2023, the band is very tight, and we should appreciate Grid India and our government of India for keeping such a tight band. Okay, this is the best example in the world. 49.9 hertz to 50.05. हम तो अभी इतना ही है ना, अभी तो कुछ इसमें नहीं हुआ. This is a very, narrow band, right? So you can understand, very narrow band, 49.9 to 50.05 hertz. Okay, and how we are able to achieve this, right? So similar kind of disturbances you will have, but because we are having the control system in place, so your faculty is there, your coordinators are there, so they will take their respective seats and they will settle within few seconds. Okay, just like your primary frequency control and secondary. Then if these two are not working, then we have emergency control, also tertiary control. Then we'll punish. Okay, so like that. So we will do load shedding also, no electricity. If you are not participating, load shedding is there. Got the point? So very good. So please take your seats. So 49.9 to 50.05, and how we are able to achieve this. See, if you talk about AGC technically, I think we are having around 50 or 53 power plants which are participating, maybe more than this little bit. So in this AGC, and their capacity is also megawatt. That is under this AGC. Itna hi hai na? So like that, right? So now how we are achieving this? I think, sir, you may be surprised how we are achieving in India 49.9 to 50.05. Okay, sir, long back there was a report by Bhanubhushan Sharma ji. Okay, and we have implemented ABT, availability based tariff. Okay, so there were three components in that: fixed component and then variable also. But when finally everything is settled, so 100. Okay, now suppose you are generator, you are not able to supply 100. It means what? You are not helping the grid, because you have said that you will supply 100 megawatt, but you are not doing that. So then there will be some penalties. Okay, so some charges will be levied. So that is linked with the frequency, right? Similarly for discounts also, if some overall is there, they will put the penalty. So in that way, by this financial mechanism in India, we are able to maintain this 49.9 to 50.05. Of course, we are having AGC. In some part, pilot projects are going on. Okay, and AGC technical part started just after the blackout of 2012. उसके बाद आपका इसमें शुरू हुआ. Okay. अब इसमें this is just for one illustration. Okay, I am not doing the complete analysis of this graph. Okay, so see what kind of intermittency. In the morning, Ranjan Behra sir was also asking. Okay, what is, see, low demand, high RE. Okay, demand is low, but your RE penetration was high. This is the real data, May 2022 report, 22nd May. Another 30th August 2022, high demand, low RE. Okay, so what is the meaning? When you are needed, you are not present. Okay, so it means what? For that, we should have some other alternative options of energy storage, right? It means you can't completely rely on renewable. Got the point? वायु देवता आपके कब तक चलेंगे, वायु देवता कब आपके बंद हो जाएंगे, अनप्रेडिक्टेबल. सूरज देवता का भी ऐसे कब क्लाउड्स आ जाएंगे, कब रेनी सीजन होगा, so quite unpredictable. So intermittency is there, right? So it means for that you should have some storage also. ये just मैंने इसके लिए आपको लिया था कि what kind of peculiar situations we are having. So when you talk about this load frequency control, so in the load frequency control we are having primary frequency control, secondary frequency control, and then emergency or tertiary. So primary is for very small disturbances. So just it means governing action only can take care of this. Okay, governing mode. So secondary loop is not coming into the picture. So primary loop is through governor mode. Okay, right. Then secondary is also through the governor mode, but not directly. That is through the controller. So your controller will give the response. Okay, how much stream should be increased or how much should be decreased like that, so that you can manage the balancing. So secondary frequency control, that is you can say up to few minutes, 15 minutes, and emergency or tertiary for the longer duration, 15 to 30 minutes. So in the emergency, it means we have some other options like you can go for load shedding also. So this is the graph. Okay. So primary I have told you, secondary also I have told you. So emergency or tertiary, that is the load shedding part. Okay. Suppose some protection issue is there. Okay. Some malfunctioning of relays. Okay. And loss of generation, loss of load for the longer period. Okay, it is in the at the larger scale, right? So then we go for this tertiary. See, this may be a very good example for AGC, automatic generation control, or load frequency control, right? So this will give you a very good idea about inertia. So why do we talk about the inertia every time? Okay, that inertia is going out of the system, right? अभी कितना हो रहा है आपका thermal तो 247 gigawatt के around आ गया out of 508 less than 50%. Okay, so it means your inertia is coming down. So what is the importance of inertia? Because inertia means you are having hydro turbines, gas turbines, and then your steam turbines, right? So inertia means what? If there is certain change in load, right? So it will give you some time to act if inertia is there. Because mass is involved, okay, rotating mass is there. So कुछ time आपको मिल जाएगा. Okay, this will give you certain time to act if inertia is there. If inertia is not there, your system will go out quickly. Okay, right? So that's why we are talking about inertia. So now in the morning they are telling that virtual inertia, then some synthetic inertia and like that. So what is the virtual inertia? Means turbines are not there. You are having solar system, okay, and battery energy storage. So you have to design your control system. Okay, your controller should be very smarter. Okay, how can you increase your generation and how can you decrease your generation? But solar, wind itself, they are having certain limitations, right? Solar में ऐसा तो होगा नहीं कि आप एक किलोवाट पे जा रहा है तो उससे ज़्यादा वो दे देगा. Not like that. So it means you have to put some regulations in place. Suppose you are having some capacity, 100 megawatt. So okay, you deliver 70 or 80, so that you can participate in peak load management also. Okay, if you are taking maximum, then there is no question. Like simple example of nuclear power plants. Nuclear power plants are giving their full. Okay, so it means nuclear power plant is not participating in automatic generation control or load frequency control in India. We are already running those plants at their full capacity. So this is the very good example. Basically, whenever you start a discussion about automatic generation control or frequency control, so see, this is the generator, this is the turbine. This turbine is coupled with the generator. This is the rotor shaft. This is your load. So you will send the frequency. Okay. So suppose your load is more than the generation. So what will happen? It will slow down your turbine. If you increase the electrical load, right? So it means mechanical load, mechanical power is also required to match with that. So P mechanical and then P electrical, right? These two should be equal. So P electrical is more than P mechanical. So your turbine will slow down. right? So it means what? You will increase the steam input so that you can speed up your turbine like that. So in that way we do it. So in the primary loop, this is the primary loop. So if some small deviations are there, your governor itself takes care automatically. For smaller, as per their group characteristic, and if you are having the controller, then they send the frequency, then they take appropriate action. So for steam and hydro, it means how much steam should be increased or decreased, and how much hydro intake should be increased or decreased by opening the hydro gates or closing the hydro gates like that, proportionately. In that way manage, right? So that is very basic example. So in our study of the LFC, because this is the coming future of this entire power sector, so we have taken this model, we have simulated, right? So here we have taken your diesel engine generator also, then wind turbine, photovoltaic, then electric vehicle, then your energy storage units, like that. We have combined all this, and this is our microgrid, and we are having both the options. You can make it utility fed also, or you can make it standalone, right? So that was also there. So in this analysis, because this is the coming future, this was our simulation model. Okay, so here not all the units are participating in this low frequency control. So in our model, your DEG, this is diesel engine generator, then your FC model. So diesel engine generator may be now biodiesel also. Okay, because our government is not focusing very much on this diesel engine generator, right? Then your fuel cell model, okay? So, and EV model. So these three are being controlled, right? In this model, solar is uncontrolled, right? So we are not in, because intermittency is there. So that is our model, and we have designed this controller, and then we have got some results also. Next, like this. So see, this is telling a lot of things about practical scenario also. So suppose no controller is there, so then some offset will remain there. Okay, so your frequency may settle below its nominal value. Okay, maybe upside or downside, like that. So if controller is there, you know, improvement is there in the frequency response. So then with controller we have exercised some other options also. Diesel engine generator, electric vehicle, then diesel engine generator, fuel cell, then diesel engine generator plus fuel cell plus electric vehicle. So you can understand this storage is playing a very crucial role, or you can say very important role to improve the frequency response. Okay, I will leave this presentation with you. क्योंकि half an hour में इतना possible नहीं था. I apologize. Right? So, okay, I am leaving here only. Thank you very much for participating.
Long live India and France friendship.